Taylor expansion. Taylor expansions are a way to simplify complicated functions by approximating their behavior near a given point by polynomials. The idea of Taylor approximations is to find the unique polynomials of degree n whose first n derivatives equal the first n derivatives of function fx at the chosen point and which also passes through that point. So this would be the expression fx equal to the sum of all the n terms, so the n times of 1 over n factorial f to the n, so that would be our derivative. So the f nth derivative approximated at the value a times x minus a to the power of n. So let's consider an example. Find the Taylor expansion of fx equal to sine x about the point x equal to 0 up to the cubic term. So in this question, we know our x value is going to be 0 and our n value would be 3, since we are finding up to the cubic term. So the first step would be computing the first and second and third derivative, since we want the cubic term. So the fx is sine x. So before that, we should know that the derivative of sine is cos. The derivative of cos is negative sine. So our initial function is fx equal to sine x. Then the first derivative would be cos x. Then our second derivative would be negative sine x. Then our third derivative would be negative cos x. The second step would be applying this derivatives in this equation. So fx is equal to, so we know the n value, which is 3. We can plug that and write the whole equation. So firstly, let's apply n equal to 1 to this equation right here. So 1 over 0 to the factorial would be just 1. Then f to the 0 at a, then x minus a to the power of n, where n is equal to 0. So this whole term would be equal to just 1. So we have f0 at a. Then if we apply n equal to 1 to this term, we have 1 over 1 factorial, that would be 1, f to the 1 here. So then we approximated a, x minus a to the power of 1. So that's right here. Then plus, we apply the n equal to 2 now. So 1 over 2 factorial would be 1 over 2. Then fn, so we have f to the 2, so we put 2 dashes, 2 primes. So then that at a, then x minus a at 2 to the power of 2. Then plus, if we now we're going to apply the n equal to 3. So 1 over 3 factorial would be, the 3 factorial would be 3 times 2 times 1. So that would be 6. So 1 over 6. Then the f to the third one. So we apply the 3 dashes at a, then x minus 3. Then, so this would be our initial function, which is fx sine x. So in this case, we are finding the value of x equal to 0. So sine of 0 here, then we find that the f dash of a, the first derivative would be cos x, so we apply the cos of 0, then x minus 0, where a is 0, then plus 1 over 2 negative sign of 0, since our second derivative is negative sin x, so we plug the 0 here, then this x minus 0 to the power of 2 plus 1 over 6. Our third derivative is negative cos x, and we are approximating for the x equal to 0. Then x minus 0 to the power of 3. So we know that sine of 0 is 0 and cos of 0 is 1. So we can cancel these expressions, sine 0 and this one. Then we finally end up with cos of 0 x plus 1 over 6 negative cos 0 x to the power of 3. So cos of 0 is just 1, so we have x here. So then negative cos of 0 would be negative 1. So this sign would become negative. Then we have this x to the power of 3 here, then divided by 6. So this would be our answer.